Triangles and scale drawing review. Okay, remember for triangles, two things need to be true. The first thing is that all three angles inside your triangle must add up to 180 degrees. And the two smaller sides, when added together, has to be greater than the third. If you look in this example, and you add your angles, 60 plus 60 gives us 180. So we know that the degrees make up a triangle. And when you add your two smaller sides, all three of these side lengths are the same. So you can choose 5 plus 5, and that needs to be greater than 5. 5 plus 5 is 10. 10 is greater than 5. So we have a triangle. Okay, the first two questions on your study guide, you're determining if a triangle can be formed. Look at your side lengths. Choose your two smaller sides. 6 plus 14 has to be greater than the third side. 16 plus 14 is 20. 20 is greater than 14, so you know your sides work. When you add your angles, we're adding 40 plus 90 plus 50, and it needs to equal 180. 40 plus 90 is 130, plus 50 equals 180. So yes, we have a triangle, and we want to classify by the sides and angles. We have a 90-degree triangle, or 90-degree angle, which means we have a right triangle, and we have two congruent sides. So we have a right isosceles triangle. Number 2, when we add our side lengths, the two smaller sides, we have 6 and 8. 6 and 8 has to be greater than 14. When you add 6 plus 8, you get 14. 14 is not greater than 14. They're equal, so this is not true, so it's not a triangle. Okay, all three side angles in a triangle have to add up to 180. So we're going to add all three angles and set them equal to 180. 5x plus 6 plus 17x plus 4 plus 6x plus 2 equals 180. You can combine like terms. 5x plus 17x plus 6x. 5 plus 17 plus 6 gives you 28x, plus we have 6 plus 4 is 10, plus 2 is 12, all equals 180. When you have a two-step equation, you undo any addition or subtraction, so we're going to subtract 12 from both sides. 180 minus 12 is 168, and our last step is to divide both sides by 28, and we get that x equals 6. They also wanted you to solve for your missing angle measures, so you're going to go back to each angle, and wherever you see an x, you're going to plug in your value of 6. 5 times 6 is 30, plus 6 gives us 36, so we know this angle is 36 degrees. Our top angle, instead of x, we're plugging in 6. 17 times 6 is 102, plus 4 gives us 106. And for our last angle, 6 times 6 plus 2. 6 times 6 is 36, plus 2 gives us 38 degrees. Okay, for this triangle, we have a right angle, and a right angle is 90 degrees. We need to make sure that we add all three angles. So 7x plus 6 plus 8x minus 21 plus 90 equals 180. We can combine like terms. When you combine like terms, we have 7x plus 8x, which gives us 15x. And we have a positive 6 minus 21 plus 90. If you add 90 and 6 together first, you get 96. and then subtract 21 gives us a positive 75. For our two-step equation, undo any addition or subtraction first. We're subtracting 75, and we get that 15x equals 105. We have to divide both sides by 15, and we get that x equals 7. Don't forget to plug that value back into your missing angle measures. 7 times 7 plus 6, 7 times 7 is 49, plus 6 gives us 55. And 8 times 7 minus 21. 8 times 7 is 56 minus 21. And 56 minus 21 gives us 35. Okay, there may be times when you are not given the triangle. If you want, you can draw out your triangle. We have triangle XYZ. We know that angle Z is 107. And angle X is 27. We want to find our missing angle. So we are adding Y plus 27 plus 100 equals, or plus 107 equals 180. Combine like terms. 107 plus 27 is 134. Y plus 134 equals 180. And then we need to subtract 134 from both sides. We get that y equals 46. So measure of angle y is 46 degrees. Okay, for scale drawings, these steps should be written in your notes. You want to write your scale as a fraction and make sure you include your units. Set your scale equal to another fraction, then you will fill in your other known value. Make sure you keep the same units in the numerators and the same units in the denominators. Put a variable in for your unknown and cross multiply. Make sure you include your units in your final answer. So for number 6, we have a model of a skyscraper is made using a scale of 1 inch, represents 75 feet. What is the height of the actual building if the model is 17 or 19 2/5 inches? So we're going to write our scale as a fraction. 1 inch is 75 feet. We know that the model is 19 2/5. You could write 2/5 as 0.4. And then you put that over x. Cross multiply. 75 times 19.4 gives us 1,455 equals 1 times x is x. We want to make sure we include our units. If this would go in with x, we know our unit is feet. So the actual height is 1,455 feet. For our last scale drawing question, our key we have is that one box equals 1 centimeter and 1 centimeter equals 3 feet. So we're going to use 1 centimeter equals 3 feet for our scale. What is the model length of bedroom 2? We are focusing on bedroom 2, and our length is 1, 2, 3, 4 boxes, which means it is 4 centimeters. To find the model width, we have 1, 2, 3, 4 boxes, so it's also 4 centimeters. We want to find the actual length. That's when we're going to use our scale as a fraction. 1 centimeter equals 3 feet. And we fill in. If the length is 4 centimeters, that goes in our numerator with centimeters. We put in x and then we cross multiply. 3 times 4 is 12. 1 times x is x. So we get that the actual length is 12 feet. If you notice, the length and the width were the same. So we know that if the length of bedroom 2 is 12 feet, Then the width of bedroom 2 is also 12 feet. And the last step is to find our area. Area equals length times width. So we're multiplying 12 feet times 12 feet, and we get 144 feet squared.